Hello, and I want to welcome you to a discussion on linear equations in two variables. That means that there are going to be two variables present in these equations, and as you can see here, there's going to be an x and a y. Those are going to be our variables, where a, b, and c are coefficients. A and b are both not going to be 0, because if they were 0, that means that variable would not exist, making it just a one equation, or one variable equation. A, b, and c are all real numbers, and let's go ahead and jump into an equation as an example in this form: ax plus by equals c. Remember, a, b, and c are real numbers. Here we see that a is 1 because it's a little coefficient in front of the x. Y has the -1 coefficient, and for b, because there's 1 right in front of that y, and then for c we have 2. 1, -1, and 2 are all real numbers, so let's go ahead and jump in. We're going to complete the table and plot points. Now what I like to do is have a negative value, 0, and a positive value to complete a table. So over here on the side, I'm going to do some scratch work. We have x minus y equals 2. We're going to plug a -2 in for x, leave y the same. We're going to solve for y. We're going to solve for y by adding 2 on both sides. We do that, we have -y equals 4, and then to get rid of that -y, we just reverse the signs, have y equals -4. So -4 is that point. For this next one over here, x minus y equals 2, we plug 0 in for x and solve for y. Have that -y equals 2. Again, let's change our signs. So y equals a -2. And then finally we have the 2 in for x. Leaving y the same because that's what we're going to solve for. When we do this, we have that -y equals 0, or y just equals 0. So put a 0 in right there. So now let's go ahead and graph this on the 4-quadrant plane using the skills that we've learned. Okay, we see we need the point -2, so we have -2, and then we go down 4 for the point -2, 4, -4. -2, -4 is right there. Let's do 0, -2, so 0, and then we go down to -2, and finally 2, 0 is right there. We want to plot those points. Remember, all it takes to graph a line is 2 points, but for this we had 3. That makes a nice line. So this line right here is the graphical model of the equation x minus y equals 2. Okay, if we continue on our discussion, notice that we have an equation y equals y equals a half x plus 3. Remember, our form was ax plus by equals c. Well, for this case, someone just solved for y. So y just equals the -8x plus c, all that over b. That's just a different way of writing this up here. All we did was solve for y in this case. But for here, we have the equation at y equals a half x plus 3. So let's just find some points. See, I'm going to do a -3. See, a -1 maybe, a 0, and 2. Let's do some of these over here in the margin. Y equals 1/2 x plus 3. This first one, let's plug a -3 in for x. When we do that, we have -3/2 plus 3. Okay, we can simplify that by saying y equals -3/2 plus 6/2. That's just a way to rewrite 3/1. When we do that, we have y equals 3/2. So 3/2, we can also say it as 1.5. There's no way to write that. Remember, you could get some fractions on this. Nothing to be scared of. But really, when we're graphing on these 4-quadrant planes, we like to have nice numbers that we can graph particularly. So this next one, y equals a half x plus 3. Let's plug in -1 for y. For x. Y equals -1/2 plus 3. And just as before, we're going to use our fractions. Remember that 3 is over 1, so we just write that as 6 over 2. We get that it's 5 over 2, or 2.5. Okay, let's keep going. We're going to try 0. So plug 0 in for x. When we do that, this is all going to go to 0, so y is just equal to 3. And then finally, let's do y equals 1/2 x plus 3, plugging in 2 for x and solving for y. 1/2 times 2 is 1, bring down the plus 3, so y equals 4. Okay, so let's go through and plot these points. So we have -3, positive 1.5, or about right there. -1, 1.5, so maybe, no, it's 2.5, excuse me, so maybe something like right here. Okay, 0,3, so what about right here? And our last point, 2, 4, so 2, go up 4. All those seem to align pretty well, so let's connect the points. And right there is a linear model on a graph of the equation y equals 1/2 x plus 3. And finally, let's talk about two other kind of graphs that you may encounter and graph them. So complete the table and graph. Let's do some negative values for x equals 4. So we have -2. Let's do 0, 1, and 4. Well, if we keep plugging x in here, remember these values will not work. But what will work? We plug 4 in, because x is always equal to 4. So these values that were originally plugged in, they will not work. But will work if we plug them in for the y side. The x coordinate will always be 4 because x is always equal to 4. So that means when we solve that, 1, 2, 3, 4, this is the line that we're going to get. And all these points here are going to be along this line. We're just going to, when you graph y equals, you get something with an undefined slope. And you get a vertical line. For this next example, y equals 3. That means we can plug every value in for y as 3, and it doesn't matter what values lie here. We can do -2, 0, 1, and 4, just like we did for the alternate problem. What's going to happen for this is that you're going to get a horizontal line when you graph y equals something that doesn't have an x in it. And those are the kind of problems that you may encounter.